All right, welcome back to Module 3. This is our last micro lecture, and in this specific module, I'm going to discuss storage classes. I'm your professor, Professor Visky, and welcome to another lecture in programming. Well, let's jump right in. So what are we looking at right now? We're looking at some programs, we're looking at a program that we have written already with a couple of functions in it. But when we talk about storage classes, what I really want to express and be explicit about is the idea that storage classes in and of themselves isn't that complicated. And there's really only three ways to look at it, right? Your storage class defines the scope of the variable that you are writing, okay? So let's look at sum of two numbers and determine value of int for a second. The sum of two numbers has a variable named sum, and the int function determine value of int has a variable called input. These two variables will never hit each other in scope because they exist within the scope of the function they are written within. And at the end of this, so at the last curly brace, this sum should be disposed of by the program. I'm not saying that it will, this is C, but it should be. Now, when I look at the scope of these variables, it's very important to note that I will never be able, within the current way that is written, to say input equals 15 or 11, sorry. And the reason why is because this is not declared at the main level. What if I did want input here, or more specifically another variable? Well, what I would do is I would write the variable outside of all of my functions. This is what we call a global variable, and it's a variable that's accessible to all the functions within this specific file. So if I said int n equals 1, this int is now accessible to all of these functions. So if I came into print name and I said I wanted to use it, I can say n equals 2 now. And guess what? I can use the function because it is a global variable as part of the storage class conversation. And I can do this in each of the functions if I wanted to. I can say that n equals 3 here. Now, please understand that when I do this, n is going to equal 3 for everybody. So if sum of two numbers fires before print name, if print name fires before sum of two numbers, print name is going to change this to a 2, and then sum of two numbers is going to change it to a 3. There's another thing I want to talk about with storage classes, and that's the idea of registering a variable. This is not something that we do all the time, but it's good for optimizing your code. Back in the day, we used to register our variables in C to make our program run faster. In today's day and age, our compiler and our runtimes are optimized to the point where that's not necessary, but it's still good coding practice. I'm not going to go over it here, but please understand that it is good coding practice. The next storage class I want to talk about is your static variable. So up until this point, int n equals 1, and in higher level languages like C# we call this a property. But int n equals 1 is a global variable. What if I wanted it to be static? What does that even mean? Well, that means that in my C application, because there might be multiple files here, when the application is ran at runtime, what will happen is that specific variable will then become a part of your program, a singleton, something that you yourself can't get rid of until the end of the program or until the program ends. And that can be good or bad depending on what you're trying to do. It doesn't change anything, by the way. Oh, and by the way, let's say I didn't want to use the int n here. I can say int n locally, and now I have a local, I don't want to say the word copy, but a local initialization of the variable in, whereas my global variable is still available, and it is still in. So you would have two instances of it. And that's it. That's all I wanted to talk about. So if you like this video, please like and subscribe. And as I say in all my videos, good luck, have fun, ciao.